Now, as I said, like autoencoder, you can have fully connected layers, you can have CNNs, you can have something else as well. And this is like a very standard CNN based autoencoder where you have input images, and in this case, it's a grayscale image. So what you do is you have these convolution layers, and the idea is you try to compress like your features to get like a very small latent code. In this case, you have, let's say 28 cross 28, this conv is giving you 14 cross 14 cross 32. Again, you have some max pooling, you have convolution. Again, max pooling convolution, you're reducing like your activation maps. And then you can flatten it. And you did that in your first assignment, so you should know all of this. And then you can have more fully connected layers, which will, let's say, give you this latent code, which has just 10 different values. Okay, so it's kind of a combination between CNN and fully connected layer. And here you can see that the total number of pixel values you have in your input data, that was 28 times 28. But this encoder is actually reducing that to just 10 different values, which means this is kind of a good autoencoder. And then what you do is, in this case, it's kind of symmetrical to like your encoder. You take those values, again, you have fully connected layers, then you can do reshaping, and again, you can perform convolution operation, then you can do upscaling, or you can also do maybe there is a deconvolution operation, but again, don't worry about it. You don't have to understand this at this point of time. But basically what you can do is once you reshape, you can perform convolution on that, right? So to increase the resolution, you can just upsample it, or you can say you can repeat the pixel values. So like max pooling was reducing the activation map size. So it was just doing, if it's max pooling, it will pick the maximum value. If it's average pooling, it will just take the average, right? So upsampling, you just repeat that value. Okay. And then again, you can perform convolution. Again, you can do upsampling, convolution until you have the desired resolution, which should mimic the input data point. And you can easily train this thing. You can actually maybe use MSE loss, which is mean squared loss. You can also use binary cross entropy loss. All of that is fine. The idea is you can compute like that loss, like pixel wise. For each pixel, you can compute a loss depending upon whether the pixel was reconstructed correctly or not. So a very simple loss could be like Elvin loss. Okay, so the way it will work is, for each pixel, you will just subtract like what your network has reconstructed with the original image. So it's just like x1 minus x2. And you just average that over all the pixels, and that could be your Elvin loss. Okay, you can also compute L2 loss, which is same as like MSE loss. Okay, so that's like a basic structure of your CNN based autoencoder.